Hello, and welcome to this quick overview of the Notable service. Today's education market includes a growing number of high-quality web-based applications that enhance teaching and learning, ranging from general communication tools and virtual classrooms to domain-specific learning engines for particular subjects like mathematics or history. Notable has emerged as a cloud-based educational platform from the University of Edinburgh's Centre for Digital Expertise and Innovation, EDINA, and is built upon Docker and Kubernetes infrastructure based within the university. Now let's log into the service and have a look. Ideally, any learning management system ought to provide access to the many learning applications available. Through the LTI standard that delivers a single framework for integrating learning systems, Notable authenticates users in an institution or a class so that any class or team can seamlessly add Notable to their toolkit within one learning environment. Notable builds on Jupyter Hub and NBGrader, so teachers and students are in one compute environment. The Exchange system enables teachers to develop and manage an assignment for students to complete and return to the teacher for feedback. With persistent storage and a browser-based UI, users can work on their computer on their Jupyter and other specialist notebooks, such as this notebook, which makes it easy to visualize COVID data that has been manipulated in Python on an interactive leaflet map. As you can see, a user can now learn and explore uses of data and libraries through Notable. Thank you for watching this short introduction on unleashing the power of Jupyter Notebooks with Notable. And if you are interested in learning more, please visit the Notable poster on the JupyterCon website or visit our website where you can contact us as well.
My name is Simon Porter. I am the Director of Innovation at Digital Science. And welcome to our companion video for our poster, Build Usability and Efficiency into Document Collaboration Workflows using Jupyter and Overleaf. Today, I'm going to take you through that workflow and show you just how easy it is using Gigantum and the lovely module that they've written called GigaLeaf. You can find the GigaLeaf module on GitHub. And indeed, you can find the code that I'm going to be using today on the Gigantum website here. So here's my standard Jupyter notebook that I'm going to use for analysis. And the only thing different is that I've included my GigaLeaf module down here. And so to connect my notebook to Gigantum, to Overleaf, I just instantiate my GigaLeaf class. And now it needs the location of the Git bridge for my project in Overleaf, which is over here. So here's my Overleaf template, fresh and new. I will get the Git location for my project and pop it into the template and then enter in my credentials. And now I will do some data science. I'll load some data, make a graph. And whilst it's generating, it will save the graph locally, and then it will add it to my Overleaf project and sync it with Overleaf so that I can now include it with a subfile command like that. I'll put that subfile command here. And the last thing I need to do is just to add some packages to my preamble. So if I recompile my project, you'll see the chart coming up on my Overleaf document over here, which is fantastic. You've read the poster, why don't you try it out?
Greetings from India. I am Vijay Kumar. I am an assistant professor in electronics. Recently, Google Colab and Jupyter Notebook have become the most valuable asset for students. The notebook what I create can be shared with students, which they can run on their smartphone browser also. This poster highlights how I simplify teaching pip and conda using notebook. The IPython kernel magic commands help run complicated scripts with minimal efforts. The poster shows installation of PySerial package using pip and conda. The magic commands help visualize the procedure and performance. And like I keep reiterating to students, pip and conda are not competitors. They have their own field to play. Details about the poster. Time command proves pip installation is faster, as lot many files are to be installed for conda installer. Pip also prepares compiled Python files .pyc as it does not have a compiler. Pip search provides packages search from PyP, whereas Conda Search provides packages from various channels such as main, free, or forge. HTML magic command helps you magic HTML pages inline. Students love this. Demystifying pip and conda using Jupyter makes students less frightened about Python, especially packages installation. To learn more about how the poster results are achieved, I am available now. We can discuss about students, my university, academics, or anything. Have a great online Jupyter conference. Bye.
Hello, I am Binu Midun, IBM Developer Advocate, presenting to you AI Ops, Artificial Intelligence for IT Operations. The digital transformation and shift to hybrid and multi-cloud architectures means a world with many independent services across environments, leading to a complexity multiplying effect known as dark debt. AI Ops is the application of artificial intelligence to IT operations to tame the immense complexity and quantity of data generated by their modern IT environments and thus preventing outages, maintaining the uptime, and attaining continuous service assurance. So how does AI Ops work? Entity linking, which breaks down silos across various data sources in IT Ops lifecycle. Advances in AI that uses deep natural language understanding, machine learning techniques, enables correlation, causality, and pattern identification for better reasoning and explanation. Out-of-the-box and customizable models using tools like Jupyter Notebooks, consumable on any cloud, connects to any collaboration platform like Slack, and AI model lifecycle management. The service correlates to a clear picture of anomalies as they occur and visibility into problems as they evolve. The insights and recommendations surface in ChatOps to help the team quickly diagnose and resolve issues. Synthesized evidence and advice is produced to diagnose and resolve the situation. AI Ops is a way to improve business resiliency. That's not a small topic given the COVID-19 pandemic has revamped work processes and business practices in a few short weeks. It can reduce cost in multi-cloud deployments as IT infrastructure now incorporates data centers, various public cloud providers, as well as edge computing resources. Thank you for visiting us at JupyterCon 2020.
Hi, my name is Doris and I'm a PhD student from UC Berkeley. Today I'll be talking about Lux, a tool that makes it easier for users to discover insights from their data. Data exploration is a crucial part of the data science process. However, the process of going from a question in our heads to discovering actionable insights is ripe with challenges that hinder the flow of data exploration. Now, the way that we do data analysis these days is we open up our Jupyter notebooks and experiment with our data through code. Note how this is really disconnected from a workflow that uses an interactive plotting tool, where visualizations can be generated with just a few mouse clicks. Without the benefits of interactive tools and notebooks, there's a substantial amount of effort required to write code that generates even a single visualization. To address these pain points, we've developed a lightweight Python tool called Lux. Lux recommends visualizations essentially for free to the users, directly into their Jupyter notebooks, by helping them visualize their pandas data frames. Lux features a very powerful intent language that allows users to specify their analysis intent in a sloppy or underspecified manner. And Lux will do its best to infer the underspecified details and automatically determine the visualization mappings. The intent can then be used to steer Lux towards recommending visualizations that are relevant to users' analysis. Lux acts as an assistant that guides users to potential next steps in their exploration by enhancing, filtering, and generalizing based on the specified intent. The intent is also a quick and dirty way to visualize your data without having to think about what that visualization should look like. Note that trying out these intent is almost effortless in Lux. By providing this abstraction for users to explore data, users no longer have to think at the level of code, but can now work directly with the concepts around the data. Lux is still a fairly new project, and we're excited to work with users interested in trying out the tool. Thank you for listening, and please check out our GitHub repository for more details.
My name is Alice Grosch, and today together with my colleague Christian Witzler, I'm going to present to you the Jupyter extension we wrote, PV-Link, short for PowerView Link, with which you can bring your PowerView visualization into your Jupyter notebook. If you have the right setup, you can even have an interactive in situ visualization right there in your Jupyter output cell. So to start, I'm going to show you a simple example of how to use our extension. So here in the first line, we create our PowerView Link remote renderer. What that does in the background, you will have to take from the poster. What follows is the normal PowerView pipeline as you would have in a PV-Python script. For example, in the last line, we call display. And now we have an interactive visualization right here in the output cell of our notebook. Because we don't have a GUI, we're going to have to interact with our data over Python commands, but as you can see, that is no problem either. Now, this is all local, which means that it's more suitable for small data, but you can also use PowerView in the classical client-server setup, with which you can visualize larger data. So here's a 64 gigabyte data set that's running on a parallel PV server. And if you take more nodes, obviously you can also visualize very large data sets in your notebook. And to show you how to do an in situ visualization, I'm going to refer you to my colleague now.
To use in situ visualization with PV-Link, we instruct ParaView to open a port to accept a simulation input from a Catalyst-enabled simulation via Jupyter Notebook. And then we can interact with it and get live simulation output. All the codes are available via a link on the poster.
Hey JupyterCon, I'm Rowan, founder of a startup called Ioxa. We're working on new ways to communicate scientific results, connecting the building blocks that make up documents to their computational origins in Jupyter.
Hey Rowan.
Oh, hey Steve.
How about we take a look at Ioxa in action?
Great idea. Steve and I are working on an article about geophysics. I'm in Canada and Steve's in Spain. I'm editing an article on ioxa.com, which is built for scientific content. One thing that's different about Ioxa is that you can write and reuse blocks of content. Each block is versioned and has comments. This block is part of a notebook. I'm going to ask Steve to fix the color map.
Okay, so let's go to my Jupyter environment. Now here I've installed a Chrome extension from Ioxa that helps me version my notebook. If we select a cell, we can see any comments. And oh, there's one in from Rowan. Let's change the color map for this cell and save it. When I change a cell, I can review the changes right here where I'm working. And then I can save that cell so that Rowan can use the updated figure. Perfect. I'll just send Rowan a note.
I can see those changes right back in my article, preview them, and pull in the updated figure. Thanks, Steve.
No problem.
We hope that Ioxa can help you get more out of your notebooks, open up other workflows for collaboration, and help you reuse cells between notebooks and beyond. We'd love it if you gave Ioxa a try. Please drop by our digital poster, say hi on Twitter, or visit ioxa.com to see more. Thanks.
We are working at the National Institute of Informatics in Japan, where we use Jupyter Notebook to manage our private cloud operations. We'd like to introduce a set of notebook extensions used for recording and sharing in our operations team. We developed NV Lineage extension to keep track of how they reuse cells. When a new cell is created, the extension gives it an identifier named meme. The extension also gives it a branch number when a cell is copied. Thus, a unique branch number is added to the cell with each duplication. Various information is recorded and shared using the meme as an identifier. The LC wrapper is a kernel with a capability to automatically store a log of cell execution. Since logs are associated with meme, the logs of cells with a common origin can be referenced together. The side stickies extension allows you to add stickies to cells that have the same origin. A comment is stored in the scrapbook cells with a meme. This comment can be referenced from cells with the same origin in other notebooks. You can also search for a notebook using meme. You can get a list of notebooks that contain cells of the same origin by an research extension. We've operated for 4 years, utilizing these tools to share information. About 100 different notebooks are now shared by multiple members, and we can track how they share notebooks with each other. All of these tools are available on GitHub. We'd be glad to have you try them out.
Hello everyone, I'm Shiva Samuel from University of Jena, Germany. I would like to present analyzing the use and reproducibility of Jupyter notebooks using Reproduce Me Kit. Is there a single reproduce button to reproduce the published results? There are millions of Jupyter notebooks in repositories in platforms like GitHub. Are all these notebooks reproducible? Could we analyze their reproducibility? I would like to introduce Reproduce Me Kit, which has a single reproduce button for analyzing reproducibility of Jupyter notebooks. It's a visualization tool where users can examine any GitHub repository and obtain an extensive analysis of different aspects of notebooks, including their structure, usage, and reproducibility features. The goal of this tool is to help repository users and owners to reproduce, analyze, and assess the notebooks in a selected repository. In the reproducibility study, Reproduce Me Kit provides information on the number of notebooks that successfully finished the executions, the notebooks with the same or different results compared to the original, exceptions occurred in the runs, provenance history, etc. It also provides direct access to tools like Binder and ProBook. For the analysis of the structure and usage, it provides information on the repository, notebooks, cells, modules, distribution of programming languages, and the versions used. It also presents a visual representation of how users execute the cells in the notebook. In its user interface, Reproduce Me Kit shows the highlight of reproducibility study on the top panel and detailed analysis on the bottom panel. You could find more information on this tool in the following links. Thank you.
This summer, we worked on a project to measure notebook reproducibility with Repo2Docker. Building on existing literature, the project investigates the reproducibility of publicly available Jupyter notebooks on GitHub in the Python, Julia, and R communities, focusing on the environment building tool Repo2Docker, which powers mybinder.org. Repo2Docker aims to automate existing best practices for environment specification, which is a claim we can evaluate by testing how often Repo2Docker produces an environment in which the repository's notebooks can successfully execute. To do this, we carried out a 5-step process to build and test images, where repositories were grouped into categories. From here, notebooks were automatically executed using a new tool, Repo2Docker Checker, that adds execution via nbconvert and images built with Repo2Docker. The results of our analysis were both expected and unexpected, and the most significant result is that a common source of build failure is strictly pinning dependencies without pinning Python itself, and this is guaranteed to fail because Repo2Docker installs the latest stable Python by default. Our results show low success rates in all categories, as well as trends in the errors that were raised. Additionally, Repo2Docker almost never identified an R or Julia repo as needing the R or Julia runtimes, which indicates that Repo2Docker's environment detection for these languages does not reflect widespread community practice. Whether this failure is due to missing community standards or a failure of Repo2Docker in detecting the standards is yet not established. Future work can expand on these results, and together, this can move open science closer to its goal of research being more widely accessible and reproducible.
Hi, my name is Nobu, a project researcher at the National Institute of Informatics in Japan. I will present Operation Hub. Operation Hub is tailored Jupyter Hub for DevOps engineers. Instead of SSHD on the management server, we set up Operation Hub. It provides notebook containers for individual operators, as for traceability and notebook sharing. These are features of Operation Hub compared to standard Jupyter Hub. Basically, Operation Hub is a replacement of SSHD server. It is provisioned onto a single server. Each operator can have isolated container environment. Each user can sudo, that is must-have for DevOps engineer. Authentication by PAM, access control or something should be consistent alignment with host OS environment. There are 3 classes of storage area. Read-only shared directory for sharing notebooks, each other, writable directory by any user for working space, and private directory to store individuals' credentials, like a SSH private key. This figure illustrates an advantage of Operation Hub because each operator segregated by container, they can use different private key for their root account. I mean, after sudo, every operator will be root. However, each operator uses different private keys. Based on that, we can distinguish which operator performs the root operation for remote servers. We can also control the access for individual operators to remote servers as well. Thanks for PKI mechanism. This figure shows major components of Operation Hub. REST user and copy password services. Those aligns authorization between Jupyter Hub and operating system. This figure shows how the storage classes are implemented. It's kind of tricky but straightforward. This table shows how the admin roles are aligned between Jupyter Hub and operating system. Deployment process is just 7 steps. Please visit our site and try it. Thank you.
Hi, my name is Felipe. I'm glad to be here presenting our work, a Jupyter Sandbox environment coupled into the high-order Navier-Stokes Solver X Compact 3D. This work aims to building a Python layer above the Fortran-coded solver in what we call the Jupyter CFD Sandbox. It provides a friendly place where students in CFD can play and learn. In addition, it works as a rapid prototyping tool for advanced users. The methodology consists in 2 things. The CFD code was modified to receive the entire initial setup from an external source. And the initial setup in turn can be done from a Jupyter notebook, taking advantage of the building documentations with Markdown, the versatility and readability of Python coding, besides all the tools that are available in the Jupyter ecosystem. So let's take a look at the workflow. For the first step, there is a user-friendly interface with widgets where the input parameters can be checked for consistency and compatibility. After that, X-ray dataset initializes all the arrays with the proper size, dimensions, coordinates, and also includes a description for each variable. So on top of that, the user can build many different flow configurations. It's also possible to insert a solid body with the immersive boundary method. Our package provides tools to build many standard geometries, and they can be combined for the creation of unique outcomes, just like the Ahmed body. After the setup, we can run the Navier-Stokes solver and analyze the results. More details are available on our poster, so please take a look and let me know if you have any questions.
Jupyter Hub is a tool for deploying notebook servers on behalf of users, deployed in a variety of contexts from classes to research groups to underpinning large notebook-based services like mybinder.org and others. We quickly saw demand for scale beyond what we initially set out to support, with first hundreds, then thousands, then tens of thousands of users. This exploded with the introduction of the Zero to Jupyter Hub deployment guide for Kubernetes. So what does a scalable architecture mean? First, it means that 2 or more hubs can be running without conflicting with each other. This would mean that we can add more hubs to handle more requests. So why can't we do this today? What makes Jupyter Hub not scalable? The main answer is in-memory state. Most Jupyter Hub state resides in an SQL database, assumptions that the hub is the only thing that can write to this database. There are also complex locks for pending transactions, which are hard enough to get right in a single-threaded async application, let alone a distributed one. The two biggest Jupyter Hub design principles at odds with scaling are 1, a single persistent database connection for the whole application, and 2, long-running spawner objects for monitoring user servers, one for each server that is running. To make Jupyter Hub scalable, database connections should be scoped per request, and we need a new system for monitoring servers such that each hub can monitor a subset of servers without duplicate monitoring and without losing track of servers. One hurdle in shifting Jupyter Hub to a scalable architecture is that there have been many optimizations to improve how many users a single hub can support, up from a few hundred to now a few thousand. Many of the optimizations rely on in-memory caching that is directly at odds with a scalable architecture, so migrating to a scalable architecture will likely have a negative impact on performance for scales that are currently supported with one hub if we're not careful. It is a big project to change the Jupyter Hub architecture in this way, and we're working on a roadmap to serve our diverse use cases, from the littlest Jupyter Hub to the biggest.
Hi, my name is Nobu, a project researcher at the National Institute of Informatics in Japan. I'll show you side stickies. This is a notebook extension for attaching sticky notes to each cell. It's a kind of another level, some meta-level annotations. Jupyter Notebook's narrative stories are efficient for sharing various workflows and engineering operations. However, it is not enough, because those narratives mainly focus on the context within the notebook itself. When you will revise, reuse, compare or something, you would like to have separate communication channels for meta, side, and reflective things. So you would like to place sticky annotations across notebooks. This is what side stick is intended to assist. Let's see how it works. Toolbar button toggles side stickies. When you click a tab that is a side stickies, associated note page comes up. Side stickies utilize Scrapbox.io service for storing notebook pages. When you click an empty tab, a new note page will be created. The initial title is the meme ID. It's a unique ID for each cell. Our extension NB lineage assigns them. NB lineage is an underlying mechanism for side stickies. Within the Scrapbox.io, the meme ID works as reference keys. Demo is available on Binder Hub. Please try and visit our site as well. Thank you.
Hello, my name is Mariana Meirelles. I'm a scientific software engineer working at Quantstack, and I am the developer of PyLess Memestra and a contributor to Memestra. Memestra is a tool that analyzes your code statically and tells you where are deprecated functions or classes. And in this video, we're going to learn about a little bit more about how to use it. And in the poster, we expanded to how does Memestra works under the hood and what is the future of the project.
Hi, I'm Stephen Mackey, and I'm excited to present NB Safety, which is a custom Jupyter kernel that uses runtime tracing and static checking to make it easier to reason about out-of-order execution in computational notebooks. To illustrate NB Safety and what it gives us, first, I'm not going to run with the NB Safety kernel. I'm going to run with Jupyter's Python 3 kernel, and then I'm going to switch to NB Safety to show the extra functionality. Let's suppose I have this simple notebook, and I'm just using it as a calculator. So I'm defining some variables, then defining their sum, then printing out. But let's suppose I need to go backwards and redefine x because I realize I made a mistake. So if I set it to 42, now the issue with this notebook is if I run it from top to bottom, I'll get output different from what I see. So this is not great. But when I switch to NB Safety and I get back to the original state that we were in before, and let's say I set x to 42, this time it presents me with a stale highlight next to cell 4, which is linked with cell 3, which has a refresher highlight, indicating I should rerun cell 3 in order to refresh z, which is stale in cell 4. And when I do so, now cell 4 has a fresh highlight, and it suggests that it's safe to re-execute cell 4, and I should do so to resolve the staleness in cell 4's output. And when I do so, I get the expected thing that I would want to see if I run the notebook from top to bottom. There's a lot I didn't get to cover in this short video. I would encourage you to check out the links in the poster for more details, including the technical report and installation instructions. Thanks very much.